what I will try to convince you is that visualization is a new language, extremely new, like baby language, you know, and that we are just starting discovering the techniques, the possibilities, the ideas, the geometries, the messages, the stories we can convey using this idea of relating information and image. One of my points is that we need a lot of creative work and creative developers, designers, and creators. People that will be creating a lot of stuff that do not match the Alberto Cairo's criteria, quality standards, because it's the only way to get to new ideas and new techniques that eventually could be used in a way they will match those criteria, right? So, but right now we need a lot of exploration, a lot of experimentation. So, why language? Well, first of all, I will try to show that visualization could be productive, generative, and combinatorial, which are some of the important typical properties of language, right? So let me start with this experiment I did some years ago in a workshop in Lima, Peru. I gave people two numbers, and I asked how many visualizations could be created to represent these two numbers. So some people said like maybe 5, maybe 10. So we were about the 10. I thought perhaps 20 or 30. I don't know. So I started doing like we started going through different ideas, and it was quite productive. Like many new ideas appear very quickly. So using ancient Babylonian notation for numbers or writing is a way of visualizing numbers. Squares, repeated icon, so it is figurative, non-abstract. Different techniques associated with areas, bars, of course, line graph, percentage, bars, etc., etc., etc. There are so many ways to represent only two numbers that imagine doing the same exercise with 10 numbers. Or what about data sets that combine numbers and text and geographic positions, etc. So it's really amazing how little we have actually created and discovered in order to represent data. So it continues. The last one is fat fonts. It's a really recent creation. It's fantastic. It's not just that the numbers are written, but also the surface of the numbers are proportional to the values. So you can actually combine different methods and different strategies. So this is combinatorial. So a lot of different ways, just for two numbers. Imagine tables of hundreds of thousands of numbers, etc. Okay. So the other thing that is important to check if visualization is a language, if it is capable to express very different things, very different paradigms or contexts or realities. So I did another experiment. I asked for people around me about what are the most important things in the world, in the universe, in our lives. So they gave me some ideas, and I built up a list of 35 important things, okay? And I created this little experiment. So what you have here is the words I collected. So the important things in the universe are the universe itself, colors, movies, cities, friendship, trade, opinion, influence, family, music, art, history, weather, etc., 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 etc. Rain, genes, evolution, names, food, war, death, and ended with life. So 35 things. And for each of these concepts, ideas, words, I try to find an interesting project, a data visualization project that will match or will address this concept. And Actually, it was quite easy. All of these projects are fantastic. So it's not just that I find a project, but always a very good project. Many of them are experimental. I believe only 5% of these projects match Kairos criteria, probably, I don't know. But I totally recommend to visit this project of mine because it's like a journey through the possibilities of data visualization. Actually, let me just tweet it right away so you have the access, okay? That's it. Okay. So you see the Fernanda and Martin map, etc. A lot of great projects to be seen. None of them is mine, okay? Okay, now I'm going to show you some projects that are created by me or I collaborated. So, no, before that, another idea is that it is universal in the sense that you don't have to be an expert or specialized in data visualization or not even in data to be able to use these techniques to communicate. So for that, I have this example. This is a curve graph of Avengers' interestingness through time, created by a 10-year-old kid that never was exposed to the idea of visualization. Actually, he didn't know the concept visualization existed. I know that because I spoke with the mother that published this in her blog. So, and this is actually extremely avant-garde in terms of visualization because he's not depicting objective data. It's his perception about a set of characters. And maybe in the future we will be seeing more of this. Not self-quantified, it's different because that's objective information about ourselves. Is how I see the world. And I can try to quantify things about my opinion or my perception of the world. So this is a good case. So it is universal in the sense that it is right there. Like our brains are somehow already prepared to use it, to create with it. Okay? Okay. Of course, it's useful to tell stories, right? We know that. We already know that very well. In that case, I will start presenting my projects with a project that tells stories about stories. So this is Lost, the TV series. I grabbed all the scripts from Lostpedia, a fan-based Wikipedia website about Lost. And you have all the seasons here. So 6 seasons. And you can go to the detail soon. Eventually, you can click on a particular episode and see the dialogues. So you can actually read the entire series that way. A little bit like if it was a comic, right? I already read like 3 or 4 episodes that way. It kind of works. So the question best cliffhanger, I think, is in history of television. I think is here at the end of the first season of Lost. That will be my bet, right? Okay. So this is a very linear way to represent this data. And as Alberto mentioned, you can always try different approaches, right? So the idea of creating a network out of the conversation is almost obvious. So I can go into the detail and see the conversations of these 2 characters and throughout the particular episodes or throughout the entire series. And also, this is quite dynamic in the sense that if I change episode, I see the network changing as well in terms of nodes and structure, right? Again, a new way to approach this, to visualize this, very related, is a matrix. And this is nice to see how sets of characters participate in different episodes and how the scripters balance it, like different stories going on, parallel stories going on throughout the series. In almost first chapter of any season, you have a choral episode in which all characters are represented and all characters interact. So it's a very rich matrix. Okay, so this it's kind of useful to identify patterns and ideas, right? And maybe writing strategies. And the final visualization is like, I call that reenactment. It's like build the episode again out of the data, out of the raw data, right? So again, you can, if you don't want to rent the DVDs, or you can use this tool, okay? So tell stories, but also it could be useful to express knowledge. This is something that particularly interests me. How to convey complex and rich and structural semantic content, right? It's not only about sharing a lot of text, it's also about being able to find the relations between the contents, etc. So I will start with a very simple experiment I did. I found in the web a 7 sets Venn diagram. It's a very strange mathematical object. I modified in a way all the subsets have the same surface, and I create this combinatory toy. Okay, so and in this case, each set has a color, so the intersection of different sets create different colors, as you see in the bottom, and I matched those colors with a colors database for names, right? So in the center you have all the colors, and the result is cliffhanger, because it's caught in the screen there. I don't know why. Okay, 2 colors, very easy, etc. So, and then you have a full-filled version, basically the same. Obviously, instead of colors, you can use categories, right? And try to use this strange object to organize contents according to the categories. So that's exactly what I did. My next step. 3,000 references from internet, including projects. Some of them are actually mine. Wikipedia articles, almost 1,000 Wikipedia articles, images, compilation videos, etc. Some people, some books, some portfolios. These are projects that I created, etc. And then number of stars for measuring how much I like those references, right? And then what you have is the intersection. So in science and technology, you have a lot of projects here. Art and science, a lot of projects. You can zoom in to see into the detail here. And you will find a lot of different contents, like Wikipedia articles, videos, or people. So Escher, for instance, is here in this subset, right? Then you have tools to make more rational search, like combining. Imagine I want something about language and humanism. So the main categories, are art, interface, science, language, technology, humanism, and networks. 7 categories. Some of you may want to ask, so is it possible to do this with 8 or 9? No, the answer is no. It's like there is a 7 sets Venn diagram, but we all know that any decent category taxonomy system is based in 7 categories, so it's okay. So you can find people that was tagged in certain period of time and related with language, for instance, things like that. Then there are more sophisticated tools. So what I try to do here is to combine like irrational or serendipitous kind of navigation, exploration, with more rational tools, and combine both in order to, at the same time, arrive into a place I wanted to arrive, but even in that place, discover new things, right? So this combination. Okay. And finally, the last point I want to do, and this I think opens also a huge window of possibilities for data visualization, is that you can use numbers and visualize them in a way you are not even showing numbers, okay? Let's see how it works. This is a project I am created with working with some people at The Economist, especially Kenneth Cukier. And we are actually exploring new ways to convey economical information. So trying to find new strategies. In that case, we have a database of 500 companies, and we have earnings and percentage of taxes paid along almost 10 years here. So we have all this data. It's a really interesting data set. And then you have like the connected scatter plot here, which is totally noisy right now. So I have to find particular companies and to identify and to see the place of the company here in the scatter plot. And etc. So I can select like more companies and compare the patterns. In the right, what you have is the normalized version of the shape, okay? If I display 10 years, it's a little bit more complex. Let's go back to 3 years, okay? So here, shapes are very different one from another in terms of also of proportion and placement in the scatter plot. But here, they are easier to be compared. Like, there is a story here. Like, Apple, for instance, starting in 2009, was paying certain amount of taxes, and the percentage decreased dramatically, right? So something happened. So we can ask what happened. The next level in this visualization is to try to find similar stories. So if I click Apple, I will find like the most correlated companies in terms of the shape, not in terms of the specific numbers. Generally speaking, correlation is more about proportional changes than values themselves. And obviously, they are placed in very different areas of the scatter plot. So, and this is a logarithmic scale. So the numbers here are hugely different from the numbers here. As we are talking about 1, 2, 3 different power difference is huge, but the story is similar. So maybe decisions in the companies are kind of comparable, at least. We can ask ourselves about that. And the final tool here is helpful to try to find companies that match certain story you want to find. So you can just draw your own pattern, and you will find the companies that match that pattern. So this, I call this, well, this is a very simple case of something that we maybe will see in the future, which is visual data science. So the visualization is not the final result of the entire data science process. It's part of the process, and you can do analytics in real time using these kind of tools, making sophisticated questions, etc. So the happiest company in the world will be something like that. So these are the companies that are doing very good. So thank you very much.